Alright, cool. So here we go with trying the practice problems. Now, you may have chosen different things than I'm going to do because it was kind of up to interpretation for you. On this first picture, it says figure out where the graph is not differentiable. So if you look at this graph, this is supposed to be sort of a sharp turn. So whatever this x value is, to me it actually looks like 5. 1, 2, 3. But I don't have my glasses on. So wherever this is on the x-axis, that is your answer. 1, 2. Is that 4? Oh, it's only 4. Okay, so 4 if you're seeing it the same way I'm seeing it. If you thought this was 1, then maybe you called it 1. But anyways, now it's a little unclear if there's arrowheads or if these stop. I'm going to assume that there are arrowheads because the graph just sort of ran all the way to the edge, which means every other spot is fine. Now you need to sketch 3 other tangents. Now I'm going to sketch a tangent at the bottom because that's easy for me. If it's ever at the top of a hill or the bottom of a hill or the vertex, it's going to be a horizontal tangent. So that would be one tangent that I draw. I would probably pick a random spot on this curve and then try to draw a tangent. Now it's going to be hard because your tangent sometimes looks like it's right on top of the line, but just do the best that you can. And then on the blue line, since that is straight, if you try to sketch a tangent over here, it's just going to be right on top. And I know that kind of breaks the rules for tangents, but this is legal. I mean, the slope is that, so you can try to draw one right there. If you don't like that, if you feel like you're breaking a rule, then just find another spot on here. Maybe right here. Draw a tangent right there, and it looks something like that. Alright, cool. Now the next part, this is where it gets fun. For all of the following, you have a big old set of directions. And I gave a point here. Okay, cool. So part A says to sketch the graph. So 4x we can do. The graph of 4x has a slope of 4, up 4 over 1. So it looks something like, oh, there we go, something like that. Part B, it says use the limit definition to find the derivative of f of x. So I'm going to do what you did last week, okay? So 4x plus h minus 4x all over h. So the limit as x goes to 0 is 4x plus 4h minus 4x over h. Cancel, cancel. Now your h's are going to reduce, and so the answer is 4. Okay. Part C says find the slope at the given point. Okay. So what we're supposed to do is take this point, okay, and figure out the slope there. Well, the x value is 1. And normally what you would do is take your slope equation or your derivative, okay, so I'm just going to write m for slope or m for derivative. You would take your slope equation and you would plug in 1. But here's the deal. The slope is 4 and it's always 4. So there's no plugging in that needs to be done because this is a line, folks. And then part D, sketch a tangent line at the given point and compare it to your answer, okay? So when I go to the point 1, 4, which is right here, if I were to draw a tangent line, it should look like it has a slope of 4. And it does because this is a line. So no big deal. All right, it should get more interesting once these get harder. So number 2 is x squared. And it's going to be at the point -1, 1. Alright, so part A is to sketch. Hopefully we all know what this one looks like, right? Just a good old-fashioned parabola. Part B is the limit definition. So the limit as h goes to 0 for x plus h squared minus x squared over h. So hopefully you have remembered your limit definition from last week. And then from here, I'm going to FOIL that out. Plus, what would that be? 2xh plus h squared minus x squared all over h. Okay, so stuff's going to cancel, right? X squared and x squared. Up here, everybody has an h. So I'm going to take an h out of everything. And it's just over 1. And then I'm going to plug in the limit as h goes to 0, and I get 2x. So this, folks, is my derivative, or my slope equation. So keep in your head, this is the slope equation. So for part C, it wants the slope at this point, okay? So this equation of 2x, you're going to take the x out and put in the x for the location that they're asking you about. So the x of the point is -1. Plug it in right here. The slope should be -2. Part D wants you to sketch a tangent line at this point. So let's go to the point -1, 1. Let's sketch a tangent line right there. So it would look kind of like that. And then you want to ask yourself, what does the slope of this look like? Well, it better look like what you got in part C. And sure enough, it does look like a slope of -2. In fact, if we were on graph paper and I drew this really accurately, you would be able to literally count down to over 1, and it would be legit. It would match up. Number 3 is supposedly the hardest on the paper. And we're checking at the point 9,6. Okay, so what do? Well, we start with drawing it. If you didn't remember the graph and you had to look it up, I guess that's okay. It looks a little something like that, okay? And what we're going to do for part B is limit definition stuff, which means this is a radical, so yay, I'm going to get to do a conjugate. Not really yay. But this is your beginning, and so remember the trick is to multiply by the conjugate. This is such a drag. Okay, and when we do that, we're going to have to FOIL. But the inner and outer terms are going to cancel. And then on the bottom, I always just recopy all of this madness. Okay, cool. So this should be what we have after doing the conjugate. This is going to be 4. Is this going to even cancel? Uh-oh. Oh, that's a 2. I forgot my 2 right here. I'm like, why isn't this working? Sorry, guys. I forgot my 2 there. There. Which means that this is a 4. Yay, that's way better. Okay, now this is a 4x minus 4x, so we're left with 4h over h times whatever, which means those are going to cancel. Cool. Now I take the limit as h goes to 0, and I'm going to get 4 over 2 root x plus 2 root x, which is 4 over 4 root x, which is 1 over root x. Did we all get that? I certainly hope so, because that's what I'm getting. So hopefully that works out. All right. So this is my slope equation. Now part C, we plug in the x that they gave us. So it's a 9. And when I plug in a 9, I'm going to get 1/3. So what this means is if I go to the point 9,6, which is way over here somewhere, and I draw a tangent line at the point 9,6, guess what the slope of that line's going to be? 1/3. Up 1 over 3. Looks pretty good to me. So that's how this all kind of ties in together. It's a whole bunch of tangent lines, limit definitions, and really, plugging in points to understand that all of these are finding the slope. Okay? All right, everybody. So next week I'm going to give you a shortcut so that something like this won't have to happen to you all the time. Okay? So we will see you next time.